I don't have too many community announcements, but I'll introduce myself first. I'm Eric. I'm with NetApp. Coordinate this meetup. I've met some of you are new. But I'd be happy to talk to you. I always put the call out if you or your company are interested in hosting a meetup in the future or you would like to present. Be happy to talk to you about that, see if we could work it out. Sometimes it's good practice for getting, if you're going to submit something to a conference, you can come and talk to a smaller group, get comfortable, get a chance to try your stuff out, calm those nerves. As far as community news, not too much going. I don't have the next meetup set up yet for March, but we'll send it out via meetup.com as soon as it's available. One thing you might want to check out, though, if you don't already know about TGI K8s, VMware, formerly Heptio, after the acquisition, they run a weekly hour to hour and a half deep dive into some topic on Fridays at 1 p.m. If you go to tgik.io, you can get a link right into their YouTube channel. It's good stuff. This week, 2 days from now, they're going to talk about Flagger. They just pick various projects and dig into them and give you a good chance to look at what's going on in a project. So definitely worth the time to view. They're recorded too, so I think this is episode 107, so there's a big backlog if you want to catch up on something or know a particular topic they might have covered. So that's tgik.io. And beyond that, another project I've been checking out lately is Octant. They just did a release, 10.2 came out. It's a nifty little binary. You download it, run it on your machine. It pops up a web browser. Whatever kube config you feed it, it goes out and gives you a graphical representation of what's going on in that cluster. It's a real interesting tool that's come out of there. So that's Octant, and it's at octant.dev. So a couple of things to check out. We're going to go ahead and move into our presentations. We've got Randy, and I'll turn the mic over to him.
Thank you, Eric. And thanks to NetApp for hosting this meetup for so long. So my name is Randy Abernethy. I'm with RXM. We're a cloud-native training and consulting shop. And we've got two pretty short presentations here with some demo code and stuff like that. So I'll just pop this up. And I'm going to do some examples and things. So I'll have to set this mic down at that point. But the idea is to kind of go through a little bit of the Kubernetes instrumentation that you would want to add to a microservice application. So if you built an app or a collection of microservices and you were just running them in Docker containers or running them in some other kind of orchestrator, you might need some of these things, but I would suggest that they'd probably be different in kind in certain ways. So the idea here is to just kind of show the Kubernetes specific wiring that you want to add to an application to make it easy for Kubernetes to know what's going on inside your app. Right? Kubernetes is an orchestration system, and it can restart your services if they're sick. But how does it know that they're sick, right? It can route traffic to your service only when your service is ready to handle traffic. But how does it know when you're ready to handle traffic? And then you can scale your services on anything that you want, as long as Kubernetes can see the metric that you're trying to scale on. And so in this first talk, we're going to kind of take a look at each of those things: liveness probes, readiness probes, and metrics endpoints. So, what does it mean to be alive? What does it mean to be ready? And what does it mean to be observable? And we're going to abbreviate the observability piece just because of the time limit that we've got. And then following this talk, Chris will take you through taking the same app that we're going to demo here and monitoring it with Prometheus and playing around with it and setting the memory limits and telling you, some tips and tricks that you can use to sort of set CPU and memory requests and limits and things like that. So all of this stuff, is really developer stuff that is not a normal developer thing. But when you're a developer and you're targeting Kubernetes, you sort of need to think about these things. You don't have to have a liveness probe, but you should consider it. You don't have to have a readiness probe, but you should consider it. And if you say we don't need this, then it should be something that is explicit probably, so everybody else knows, yeah, this service doesn't need those things. If it's running, it's good. But that's not always the case. So liveness, or how to avoid getting restarted when you're actually just resting. Pulp Fiction snap there. And then the next kind of slide that you see here is showing a Kubernetes pod liveness probe. So when you run a container, Kubernetes just executes it, and as long as the process is running, it assumes that that container is ready and healthy, which could be a false assumption. And so in order to instrument an application to give Kubernetes more information, we can create a liveness probe. So you can see that containers are the things that contain processes that are actually running, right? The pod is just a kind of a bunch of configuration around a set of containers that share namespaces and whatnot. And so in the example here, we're saying, hey, run this program and execute the following command, cat temp healthy, and wait 5 seconds before you start doing it, and do it every 5 seconds. So there's obviously some tuning that you have to think about when you set up a liveness probe. If you're hitting your app too often, you're going to be loading it, and it could potentially impact your performance, right? It could increase the latency of the actual service itself. So you don't want to ping it too frequently, but if you ping it too infrequently, then of course it could be dead for a while before you notice. So picking a happy medium there is something that could take a little bit of trial and error. And I point out again that if you're a developer, this is your domain. The ops people don't know your software. They don't know how you wrote it or what's going on inside there, and they really can't figure out this stuff for you without just brute force trial and error. The developers that wrote the software are going to have much better insight into what's needed here. So developers, DevOps teams that are building the manifests that actually run their pods in clusters are the ones that are generally going to be responsible for doing this sort of stuff. So what I'm going to do is give you an example of a liveness probe, and got a little SSH session set up here. And maybe before I actually jump in, let me walk you through the code a little bit. Okay, so this is the service that we're going to play with, and it's just a really simple service written in Go. And so you can't see that at all. I'm going to see if I can make that a little bigger. Let me set the mic down. Okay, so this is just a simple Go service. We've got some variables that we've set up here to keep track of some metrics and some other stuff. We'll kind of look at those in a minute. But this service has a simple function that just allows you to ask for trash levels. The premise being, hey, what if we had this machine learning system that could use the Internet of Things, and all of our trash cans were smart and just sent us over, low power wide area networking, the levels of their trash, and we could just collect the ones that needed to be collected and not waste time, going to ones that don't need to be collected, and we could also avoid trash all over the street. Right? So this guy is going to report to you the levels of all the trash cans after it receives the data on the back end. So we've got a larger application that this is a piece of, but we sort of dumbed it down here. So this level handler gets called, and he keeps track of the duration that this call takes. If you're not a Go programmer, this is basically getting the start time at the beginning of the call, and then defer in Go just says run this function at the very end, right? If you exit for any reason, run that function, and so that's going to snapshot the end and give us the duration, and we'll save that. The next thing that we do is we just grab the ID that the user is looking for. We log a message saying, hey, we're going to return that ID. And then we've got a little delay that we're computing here. Based on how much memory this app has allocated, it's going to act faster or slower, depending. It's all simulated, but the idea is that, hey, if you gave the app more memory, it might go faster. And so Chris is going to specifically talk about this and how to figure out what the sweet spot is and that sort of thing. And so we just set up some headers and return the ID and the trash level. So that's the main service interface for this app. And then we've got the mem handler that we use for just allocating more and more memory, right? So that when you call that endpoint, it's just going to allocate memory, and that's going to make it go faster. And then we've got a kill handler. So this is going to this is going to tell the app that you're not alive anymore. So you can imagine lots of scenarios why an app might be in memory, a process is live and running, quote unquote, but is in a scenario where it can't respond to users. For example, it could be in a deadlock, right? Thread A has lock B, and thread 1 has lock 2, and each wants the other. And so no progress, right? Endless loops, the list goes on, right? There's lots of reasons that a service could be having big trouble. So we've got an endpoint that allows us to, artificially kill this guy. And then we have a liveness handler that just looks at that live variable, and if you're live, he says, hey, 200 OK, and if you're not alive, he returns something else. Status service unavailable, that's 503. That's a pretty common one. 503 will shed load in a lot of environments and cause the load balancers and things like that to send traffic elsewhere. But in Kubernetes, any liveness probe that returns something other than 200 to 399 is going to be telling Kubernetes I'm not alive, right? And if you tell Kubernetes you're not alive, it's going to restart you. So we'll be able to kind of see how this works. So let me go ahead and just quickly run this guy, and then I'll kill it, and we'll see how the liveness probe works. Okay, so I'm just listing the pods that are running, and you can see that we've got 2 of these trash level guys running, and these guys have IP addresses, and we can curl them. Let's go ahead and try. 1032.0.5, we're going to hit the health endpoint for this guy, and it says alive, right? But what's more important is the status, right? Kubernetes doesn't care what the JSON message is. It cares about the status, and so we've said 200 OK, right? So this means that this guy's good. And so if we tell this guy that we want him to die, let's just quickly go back here and verify. Kill. Okay, so kill is the route that invokes that kill handler. So we'll go ahead and hit that. Now notice we're picking a specific pod, right? 0.5. If we went through a service interface, who knows which pod we would be killing, right? But it would be pretty obvious fairly quickly. So notice all of the reporting information on these pods, right? You can see the 2 pods are both ready, 1 out of 1. That means the containers in the pod are ready, right? So container 1 out of 1. There's only 1 container in these pods, but if there were 2, it'd be 2 out of 2, or 1 out of 2 if you had issues. And so you can see restarts. That's another key thing to watch, right? If a container inside a pod has issues, it's going to get restarted. And so you want to see a restart count, obviously, of 0. If you don't see that, then probably there's a problem, and it deserves some inspection. So we'll go ahead and kill this guy. And it says, OK, 200 OK. You said kill, and so that worked, right? 200 OK, and the message is he's dead, Jim. And so, no Jim there, but so now let's go ahead and do a health Z. And interesting, right? Service unavailable. This guy's dead, right? And so the interesting thing here, if I go back and look at the pods, is as far as Kubernetes is concerned, everything's fine. And the reason is the manifest we use to launch this guy doesn't have a readiness probe. So this is a pretty typical scenario, right? The app is dead, but Kubernetes has no way to knowing. Your process is in memory, right? It didn't terminate. It just won't answer requests anymore, and Kubernetes has no way to know that. So we can fix that with a readiness probe. So let's go ahead and do that. I'm going to set the mic down and just do it real quick, and then I'll talk about it after. So I actually ran this guy as a deployment. And what I'm going to do is I want to get that deployment trash levels. And I want to also output it. So I'm going to do a -o YAML, because I know if I type it, it'll be wrong. And so there is the manifest that I'm currently running. And as you can see, the spec for this set of pods, or for the set of containers, where there's only 1, doesn't have a liveness probe, right? So I'm just going to copy and paste this into a brand new manifest file, and then I'm going to edit it down a little bit and add the liveness probe. So let me do that real quick. kill the other guy. Okay, so so we've got the basic spec stuff here. There's a lot of things that we don't need. I'm just going to do a simple spec with 2 replicas, and we'll leave the selector in there. The rolling upgrade strategy, that's pretty much a default. And then the template for the pod itself is going to include the container, and we've got the port, some resources. Chris is going to get into the resources coming up. Don't need a termination message. Don't need any specific DNS stuff. Restart policy always is good. We'll use the default scheduler, and I'm just going to get rid of the rest of this stuff. OK, cool. So that's that. Now, what I'm going to do, rather than typing anything here, is I'm going to just go to kubernetes.io and get a Liveness Probe. All right, so this is the great page to find out about all this stuff, the configured liveness and readiness. And so, so you can define a liveness command here. This is a liveness probe that's going to execute an actual script inside the container, and if that returns 0, then you're healthy. Anything else, and you're not healthy. The other possibilities are to use an HTTP GET. So here's an example of that, and that's what I'm going to use. Right? Because we actually have a health Z endpoint. And while I'm copying this, I'll just give you a little background on the health Z. Health Z is an interface scheme that Google came up with because their normal interfaces, you know, they didn't want to bump heads with their normal interfaces when they were doing their operational stuff. And so they added a Z to the end of all the operational interfaces, like health checks and readiness and things like that. And so that's the convention that sort of cropped up there with many people using health Z as an endpoint for checking health. And so I'm going to just line this up. And so that's it, right? Our service is listening on port 8080. So we're going to do a health Z hit on port 8080. And so Kubernetes is going to start hitting our service. And you know, as we run this deployment and checking to see that we're healthy, beyond just looking to see if we're running. So let me kubectl delete deploy, and then that guy is trash levels. I don't know if that's the name of it. Let's try. Oh, it was. OK, good. All right, so so here is our deployment, and so now I'm going to kubectl apply this new deployment, and let's see what happens. OK, so let me just check here, make sure we got the right syntax. So Liveness Probe at the container level. I might have it off on the indent a little bit. This is why I don't type YAML whenever I can avoid it. OK. Yes, right. So let me just delete the restart policy. That's the default anyway, and then drop this down to the container level, which is, of course, going to test the container. And if you had different containers, you're going to have different liveness probes for each one of them. OK, so let's try it one more time. Hey, OK. All right, so now kubectl get pod. I'm not going to output wide. I'm just going to do a regular one. And so there we see that we've got these guys ready. Everything's happy, just like before. And so let me output wide to get the IP of one of these guys, and let's kill him. So we'll go back to our curl command here, and we'll hit well, let's hit the health Z first on, let's say, 5. OK, so we got the same IP, so that's good. OK, so message alive, good. OK, so now let's kill this guy. OK, so he says he's dead. Let's try to get a health Z. And he says he's dead. OK, well, that's interesting. Let's take a look at what Kubernetes thinks. This is our .5 guy. OK, so take a look at the restart count, right? So the kubelet the kubelet, which is the agent on the node that's doing all this work, right? Because it wouldn't make any sense to have the control plane testing all the pods running all over the place, right? If you have 1,000 nodes, you want to have all these tests being done locally, because you could have 30, 100 pods on a given node. And so the kubelet is doing these tests, and he has a refresh cycle, right? So we had to wait for a little bit, but after a while, you can see he said, oh, hey, that guy's not healthy. He returned a 503 to me, and I'm expecting a 200, 300 series response, so he must be sick. I'm going to restart him. And so there's our restart count, right? So that's the kind of instrumentation that we can add to our microservices to really just make them more, Kubonic, right? So that's a Liveness probe. So let's take a look at the next option. Liveness probes can be executables. This works good if you have, for example, a prepackaged image that you didn't have a lot of control over, right? Maybe you're getting Cassandra or something, and you're using the source repo, building it, creating a containerized image, and there's no easy way to set up a Liveness probe. So instead, what you could do is you could create a little script that calls node tool or something and checks to make sure all the Cassandra nodes are happy and returns 0 if it's successful and something else if it's not. So you can always hack together a script and drop that in the image. The other Liveness probe you can do is a HTTP GET, like we just demoed. And then the final one is a TCP socket. This is sort of a cop-out. This is where the kubelet just connects to a port, and it has to be a TCP port. And if the connection succeeds, he says, oh, you must be OK, which is a little specious perhaps, but better than nothing maybe. So those are the 3 options that you've got. All right, so now let's talk about readiness. Just because you woke up doesn't mean you're ready to swing at a 95-mile-an-hour pitch, right? So readiness is the thing that tells Kubernetes this pod is ready to accept traffic. And so imagine a MySQL instance that you're running in your Kubernetes cluster, and you start it up, and it's got a messed up transaction log, and it's going to be 10 minutes before it has recovered and rebuilt all the data files and is ready to actually accept connections. Well, if it says I'm healthy, then Kubernetes will start sending traffic to it if you don't have any other mechanism to tell it not to. And of course, that traffic's going to bounce right off. It's not going to be answering. It's not going to accept connections. So that's no good. And the other issue is that if you report that you're unhealthy as a way of shedding traffic, you'll keep getting restarted, right? Which is no good either. So there's really completely orthogonal concepts, right? Am I healthy, and can I accept traffic, right? So the readiness probe is the can I accept traffic question. And so the kubelet, if you set one, will call that as well. And it will decide whether to send you traffic based on your readiness. And so if we test the pods that we've got through our service that we've got set up in here, we should be able to see that we can use a service to reach a pod on the back end, and it won't matter which one it is. But if one of them is unready, all the traffic will go to the ready one. So I'm going to demo a readiness probe real quick here so that we can kind of see how that works. Let me first go to the code. How's my time? OK. I don't want to use up all the time. OK, so here's the code for this readiness probe. So the readiness probe, a lot like a Liveness probe. And in this example, same thing, right? We've just got a flag value ready, and if you call the API interface that sets ready to false, then he's not ready anymore. So let's see how that works, right? We will check the ready Z interface, and we will make this guy not ready. Okay, so right, this one's actually pre-baked. So here's the logic in this one. We're ready false, right? So we start up, we're not ready. And then what happens is we're actually going to run a go routine here, which is going to time sleep for 30 seconds. And then he's going to set ready to true. So essentially, if we enable the readiness probe, we won't be allowed to accept traffic for 30 seconds. And you'll see it in the pod output. So let me go ahead and add the readiness probe, restart the deployment, and then we'll do the dump of the pod stuff. So here's a kind of a handy trick. A Liveness Probe, a Readiness Probe, they sort of look the same. So I'm going to just yank these 4 lines, pop them in. Oops. A little too much. There we go. Okay, so we'll make this a Readiness Probe here. Kubernetes is case sensitive and spelling sensitive. Okay, and so this is the ready Z interface that we want Kubernetes to check. All right, cool. So let's save that and see what happens. Okay, so let's look at our pods real quick. Aha! They're not ready. It's the exact same app, right? But because you didn't instrument it the first time, or I didn't instrument it the first time, Kubernetes had no idea that you're not ready. And he would have sent traffic to you through the routing mesh, right? And third-party tools like Istio and things like that will look at this stuff too, right? And so if I keep refreshing this, at some point, these guys are going to be ready, and traffic will be allowed to flow to them. It's 30 seconds, right? So 10. Oh, hey, one of them's ready. That's weird that we caught one. Okay, there we go. So now they're both ready, right? So that's the example of the Readiness Probe. Okay, cool. Last one. So some probe settings. Oh, this is useful. So if you, for example, maybe you can't even do a health check for a little bit when your app starts up. You can say, I would like you to delay, X many seconds before you ever, do a Readiness Probe or something like that. So that's an initial delay. That can be set. You've got a period, how often. We looked at that. Timeout. This is an interesting one. What if I hit the HTTP GET, I get a 200 OK after 20 minutes? That's not OK, right? You're not OK, right? So there's a timeout, and you can set the timeout so that you can say, hey, look, if the service doesn't respond in a second, then there's problems. You've got a success threshold, so this is the minimum consecutive successes for the probe to be considered successful after it failed. So if it says, hey, I'm not ready, how many times does it have to say it's ready before you add it back into the load balancer or the service mesh or what have you? And then failure threshold, when a pod starts and the probe fails, Kubernetes will try failure threshold many times before giving up. HTTP probes also have some extra settings. You can set the host, the scheme, so HTTP, HTTPS. You can set a path. You can set headers if you need to, and the port. Okay, so the last piece is metrics. So tracking resource consumption. So this ties into observability, and it's kind of going to dovetail right into what Chris is going to talk about. There are 3 areas that a lot of people kind of focus on when it comes to observability. One is events. And so events are things that happen, right? People, get connections, so they record that event, right? Hey, I just got a connection from a client. I just returned some data, so I record that event, right? So these are things that happen at a point in time, sort of async. And in Kubernetes, there are kind of 2 levels of logs. There's the control plane logs, which are retrievable through kubectl get event. So if I do get events, that shows me all of the events that have happened in my current namespace. And then, of course, if you want to look at the log data of a particular pod, you can do that as well. So kubectl, thank you, logs, and then let's do trash. Let's grab this guy right here. So we want to see the logs of this guy. Now this guy only has 1 container, so he's not going to ask me which container you mean, but normally you'd use a -C switch to pick which container. And you can see that he started up and said, I'm listening on some port, right? So that's the log output. So you have these 2 levels of logs. You have the applications logs, and then you have the control plane logs. And you often need to put them together to figure things out. And then you have metrics. Metrics are resource consumption statistics, and they tend to be time series, right? So how much CPU is the pod using? How about now? How about now? How about now, right? So you'll get samples over time, and you can plot that, and you can predict, we're going to run out of memory. We're going to run out of CPU, right? Because you can draw trend lines and things like that, which is really useful. And then you've also got tracing. So if I say, one microservice says, hey, a user connected and asked for a list of customers, and that guy then calls somebody else, how do we know that the end user's call from customer A caused that next call, right? These microservices could be handling lots of clients, all interacting with them at the same time. To be able to track the context of a call through a system is a little tricky. And so tracing actually handles that. And there's two big ways to do that. One is with a proxy, but the proxy, again, doesn't really know the context. It can put in headers and it can tell you who's talking to who, but it doesn't know about the initiator of that chain of events. Now, to do that, you have to instrument your code, and open metrics and things like that are used for that. And we got at least one Uber person here, so really cool tools like Jaeger and things like that can help there. App dynamics and various other things, right? So yeah, it's a little shout out there. So that's really where I wanted to leave it. This app also has a metrics endpoint that will tell you how many times it's been hit and things like that, but Chris is really going to cover that. So I think the plan is like a quick 5-minute break. We do a changeover, and then we'll let Chris take over.